What's going on, everybody, and welcome to Project 3 of our statistics class together. The theme of Project 3 is essentially that we're going through probability distributions, and so you're going to be adding two additional sheets onto your set of tools here. One that's a discrete probability distribution and one that's a continuous probability distribution. So we'll have a flagship example of each one of those. Namely, for the first one, we'll be doing the binomial distribution. That's a very useful discrete probability distribution, one that we'll be using an awful lot. And the other is going to be a normal distribution. That's the most common continuous probability distribution. So if we take a look at what is to come here, let me show you what this is going to look like. We're going to have two additional sheets here. One that's the binomial distribution labeled binomial. The other one's going to be the normal distribution. I think that for this video here, we're going to focus just on doing the binomial distribution, and then I'll record a second video for how to do the normal distribution. So, how do we do this here? Well, let's open up your statistical tools document here. We're going to be adding another tab down here, so we'll be clicking on the plus sign here, and let me move this over to the right, and we're going to rename this from sheet 5 to just binomial. Okay, we're going to give it a good title up here on the top of the binomial distribution. I can type. Right up here, and I think I'll make it boldface and 18 for that. Good title there. Just like before, we're going to be using input and output parameters that we're going to be inputting into this, and then of course getting output from it. So let's start off with the input parameters. And there's going to be two of those. There's going to be an n parameter for the number of trials, and there's going to be a p parameter for the probability of success on each trial here. And so let me just put in some example values here of 10 and 0.5 for the probability. Remember, probabilities have to be between 0 and 1. And let me make this boldface right here, make this boldface, and then also indicate that this is an area of input. In other words, it's one of the parts of the spreadsheet that you can actually touch, and the other ones you don't want to mess with after you've made the spreadsheet. So I'm going to color this a very light green color, just to indicate that that's a place where you can mess with the parameters. So those are the input parameters here. Now let's take a look at the output parameters. Jeez, I can't type today. Okay. And those are going to be in two sets here. There's the first one we want to calculate is the mean of this probability distribution we're going to be creating. We also want to calculate the variance and the standard deviation. And so those are going to be some things that we calculate as well. Let me indicate this as being bold, as well as these being bold. Let me also put some borders around those parameters here. And then there's going to be a second set of output parameters that will be a set of percentiles here. And if you recall, the 50th percentile, that's the center of the data, that's also the median. In the same way, the first quartile is also the 25th percentile. So if you're 25% of the way through the data, that's the first quartile. If you're 75% of the way through the data, that's the third quartile. Then, of course, you have all the other percentiles that we can put in the middle there. So let's list what those are here. So for this, let's do the first percentile. So that's close to the bottom of the probability distribution, but not the actual bottom. Let's do the 5th percentile. Let's do the 10th percentile. The 25th percentile, also known as Q1, the 50th percentile, also known as the median, the 75th percentile, that's of course Q3, the 90th percentile, the 95th percentile, and lastly the 99th percentile here. Okay, and I'm going to make all of these boldface. I'm going to enlarge the size of this column here so that it encompasses everything. And then I'm going to create a little grid here that encompasses all these calculated values here. Okay, so that's all done. Now let's go through the process here of actually creating this binomial distribution here. And again, the binomial distribution is a distribution that describes the list of probabilities for the outcomes of a set of trials. In other words, if you have a set of 20 trials, for example, in which you're rolling a single die like we did in classroom, that's you have a number of trials of 20. And for example, if you're trying to see how many times you roll a 6, well, the probability of rolling a 6 each time is 1/6. And so those are your two parameters here. That's actually your N and your P sitting right up here. So those are your parameters to this. And the binomial distribution is going to give you the probability that if you roll that dice 10 times, you're going to get 0 6s, 1 6, 2 6s, 3 6s, all the way up to 10 6s, which would be very, very unusual. So you'll have a very, very low probability for those. You're going to find it's actually a skewed distribution. If the probability is less than half, it's going to be skewed to the right. If the probability is around a half or so, it's going to be a symmetric distribution. And if the probability is greater than a half, you're going to find that it's skewed to the left. Okay, so let's see what this is going to look like here. And let me first of all, let's see, we want to start up in here. So I'm going to indicate here a 0 for our starting x value right up here. And then I'm going to go 1, 2, 3. This is the set of x values that might be input into this distribution here. And we have to make a decision here on how big this can get. And so let's make a decision here that we're not going to do more than 50 trials. And so I'm going to select all of these data right here. And since I've entered in enough cells here that it's going to get the idea that you have to just add 1 each time as I scroll down, I'm going to just click and drag this down here until... Very good. So first try. Sometimes I overshoot, sometimes I undershoot here, but you can see we've gone all the way down to 50, which is what we want. And we should start at 0. Make sure you start at 0. So 0 all the way down here to 50. This is your distribution of possible x values. Alrighty. And so next to this, we're going to be calculating in here the probability that for example, let's see, what would be something that has a probability of 1/2? Well, that would be like a coin flip. All right, and so how many times are we flipping a coin? We're flipping the coin 10 times, and so let's say that success is getting tails. And so this would be, what we're going to find out here is the probability that if you flip a coin 10 times, you're going to get 0 tails. In other words, all heads. So the way that works here is we're going to be using a formula in Google Sheets called binom.dist. Binom.dist. All right, so maybe I can zoom in here a little bit. Oh, it's not going to let me do that. Tell you what, I'll zoom in after I've typed it in here. And the first parameter in binom.dist is going to be this x value here, this number of successes here that perhaps you can see on your screen. Number of successes there, so I'm going to click on this for 0 right here. That it's going to find out, okay, it wants to know what the number of trials is. Well, that's n, and that's sitting over here. I'm going to hit comma, and now it wants the third parameter here, which is probability of success. Well, that's p. Here, so I'm clicking on that. So I have 3 parameters here, this, and this, comma, And the last thing is whether or not it's cumulative. So if I put true, it's going to plot the cumulative distribution. If I say false, then it's going to plot the probability distribution, not cumulative. So I want it to be just the probability distribution here, so that's going to be false in all caps. And then I have an in parentheses there. And if I hit enter there, then I'm finding out, as I zoom in, that the probability of getting 0 tails when I flip a coin 10 times is actually very, very small, less than a 0.1% that's going to happen here. So here's the formula up here. Once again, I'm using binom dist. That's the name of the formula here. And here's the first parameter here. It's taking in this value here. Second parameter, it wants to know the number of trials. Third parameter is the probability. And the fourth parameter just indicates that it's not a cumulative distribution. We actually will do a cumulative distribution in just a moment. All right, so now that we've got this, we're going to end up filling this, this formula down. And as it's filling down, it's going to switch this first parameter from here to here to here to here to here and so on as we're filling this down. Well, that's fine for this first parameter here, but I don't want the location of these parameters to change at all as I'm filling this down. So for the second and third parameters here, I want to stick some $ in front of, in this case, B and 4, as well as B and 5. Now that says that when I'm filling this down, I don't want it to move the locations of the inputs at all. Here D4 can become D5 and D6 and D7 as I'm filling this down, but I don't want these locations to change at all. Okay, so there's that one. And I'm just going to fill this down a couple of spots here to show you what I mean. So again, I've clicked on this little box here, and I've filled this down a couple. And so if I click on this cell here specifically and take a look at this formula here, you'll notice that for its first parameter, yeah, it's now looking at the 2, not the 0 for its first parameter, because this one shows the probability that we have 2 successes, 2 tails out of 10. These 2 parameters are still, however, looking at these 2 locations, so these 2 don't change as I'm filling them down. See how this works? All right, so what I want to do is continue to fill this down all the way down to 50, and actually we should get some errors when we do that, because after 10, this doesn't make any sense. How can you have 11 successes out of 10 trials? How can you have 11 tails when you're only flipping the coin 10 times? That doesn't make any sense. And so that's fine. It's okay. We can leave these errors here for now. Actually, let me see if there's anything that I do here to control for that yet. Okay, and the answer is no. So I think we can leave that as is. I want to actually repeat this again in this third column. So I'm actually going to retype this in here. I'm going to do a different version of the binomial distribution. This is going to be the cumulative one. And so the parameters are basically going to be the same, except that last parameter is going to be true instead of false. So once again, binom dist, and number of successes, again, that's 0. Number of trials, that's also here. Hitting comma, probability of success, that's also here. Comma, cumulative, this time cumulative is true. In all caps, true in all caps. All right, and so you can see here the cumulative distribution is actually the same for this first value here, but as we fill this down, it's going to eventually increase it all the way up to 1 when we get to 10 possibilities here. So 10 tails out of the 10 trials. Let me do the same thing as before here and put $signs in front of B4 and B5, so that when I fill this down here, it's going to follow things appropriately. Good, that's good. This becomes a 1. And as I fill these down, these are all just going to give me an error, but that's okay. It's going to be okay. So we've got this here. You'll notice that as I change the parameters, let's say 10 to 20, that changes the values that we see here, so that now 20, all the way up to 20, we have reasonable sets of information here. Beyond 20, it's unreasonable because, again, 26 successes out of 20 trials doesn't make any sense. Okay, so all of these, just like before, we kind of had one set of parameters that we were calculating, and then we kind of hid those, and then we recreated them to the right in a way that made it so that when we had all these errors right in here, we didn't actually show it. It turned into just blank space, so that we could show a cleaner version of this probability distribution, and also make it so that those values don't show up when we plot this as a bar graph. So let's do that very thing here as well. We're going to have 3 columns here to the right. The first one's going to be x. Second one is going to be binomial dist. And then the third one is binomial dist cumulative. Okay, so those 3 right there. And so then I want to make it so that if this is, in other words, if this gives an error of some kind, or should give an error, then I want this to just show a blank space. And if not, show this value here, which is our actual x here. So, so these 3 columns are going to be repeating these 3 columns, but showing a blank space whenever there's an error. Okay, so let's start off here. The way that we do this is, for this formula here, I'm going to make an if statement. So equals if, and the big question is whether or not this value, this x value, is less than or equal to, see what I did there? Less than or equal to n. Okay, because if it's if that's not true, then everything should be blank. All right. And the way this if statement works here is that you put in this logical expression here. This is either going to return true or false. If it returns true, then this number is less than this number. That's okay. Show the information that's in D4. Okay. Comma. If it's false, I want it to be blank. And once again, I want this location here not to change as I am filling this down. So instead of just D4, I want it to be $D, $4. Oh, no, I'm sorry. That's not the one. It's B4 that I want to be $B, $4. Okay. And we like this, a suggested autofill. Yay. So that makes it so that it's filling it in there. You'll notice that after 20, because n is set to 20, after 20, it just leaves things blank. Okay, so we don't see any of this stuff here. So this is a cleaner version of this column here. We're just basically going to do the same thing now for the other 2 columns. Same thing here. So for binomial distribution, we're just going to do a repeat of this second column here, making it blank if it's really not valid. So equals if, it's the same question again, is this less than or equal to this? If it's all right, I'm just going to immediately put in the dollar signs here. $B, $4. So if D4 is less than or equal to B4, if that's true, then go ahead and copy this over. So E4 is our answer there. If it's false, let's make it blank. Okay, and keep this in mind here. Make sure that these quotation marks are right next to each other, not quotation space quotation, but quotation quotation. So just leave it as it is there. Right parentheses, and there we are. And suggested autofill once again. Okay, very good. So that's taking place there. You'll notice that just like before, it's cutting off and making everything blank below it. All right. You can probably guess what we're going to do for this third column here. Equals if, once again, it's the same condition. D4 is less than or equal to, I'll just type it this time, $B, $4. That's our logical expression. If it's true, then go ahead and copy this column over, or this value in the column over. And if not, let's make that blank. And yes, let's autofill that. Nice. Okay. So very, very good here. Let me make it so you can only see the screen here. I think this would be helpful if we just do this. I'm going to zoom out now. And I'm going to do a couple of things here where we've got, let me first of all make these nice and pretty. Boldface, centered. That'd be nice. Let me widen this a little bit here. Okay, so that looks pretty good. And then I think I'm going to put some borders around this. First of all, just the borders in general here. Let me click somewhere else and then click it again. And then come back and I'm going to click on this and switch this to a larger border for the outside. Okay, so I get this. All right, so very, very good here. You know, once we've got this in a nice form, we really don't need these three columns, but we need to have them doing their thing, right? We need to have them functionally. If we were to delete these things, then suddenly these columns wouldn't have any information. They wouldn't know what to do. But what I can do is hide them by doing this. I'm going to select all of them. And then for the text color, I'm going to make it so it's not black any longer. It's white. Okay, so if I do that, then suddenly all these numbers are still in here, but we can't see them because they're written in white. So what I'm going to do now is make these columns a little smaller. Again, the numbers are still in them, but we can't see them anymore. So they still have the same functionality, but it's nice in that we really just want to focus on this part here where we have the helpful information. And again, if I change n here to 30, then it should fill things down to 30 now, which it does. That's good. So we can see our binomial distribution here. And if I change the probability to 0.2, that's going to change our numbers here. It still fills it down to 30, but as you can see here, things drop off pretty quickly once we get above 20 or 22. Guess what? We want to graph this. So what I'm going to do is start with X and binom dist up here, and I'm going to select this entire thing here all the way to the bottom. And I'm going to say insert chart. Okay. So you can kind of see what the shape of this thing is here. And I'm going to move this to the top here. So that's just right next to this thing, nice and neat. And you can see it's pulled up the setup editor up here. I don't want this to be a line chart. I want it to be a bar chart. So I'm going to switch it to our column chart here. So you can see, and think to yourself, why would I want this to be a column chart instead of a line chart? And the answer is that if it's a line chart, then I'm sort of implying that 1.5 on the x value also has a value on the y in the y direction, but there are no values for 1.5 or 6.7 or 10.3. All right, these are discrete values that only have answers when we have whole numbers here. And so it's really more appropriate for us to describe this as a discrete set of bars here. Okay, so that's that. Binomial dist. Let me actually change that a little bit here. I'm going to click on Customize, Chart and Axis Titles. Instead of binom dist versus x, I'm just going to say binomial distribution. And I think I'll do the same thing for the vertical axis title. I think I'll also call that binomial distribution. Okay, so that's looking pretty good here. Let's see what happens when I make n really small. I'm going to make n just 5 now, so it should now only show 6 columns when I do that. And as you can see, it does 0 to 5. So we're only seeing 6 columns here. You can see here that when the probability is small, this is a skewed distribution here. And let me make it even smaller. So you can see here that when it's small, then this distribution gets a little skewed here. You don't really see much on the left-hand side, but you do see a lot on the right-hand side here. Yeah, that's a little easier to see here. So very, very skewed when we have a small probability. When the probability is near 50-50, then it's nice and symmetric, like this. If the probability is really close to 1, then it becomes skewed, but in the negative direction. This is left skewed. All right, so a lot of properties that you can see with this based upon what you're seeing here. Let's also take a moment here and describe what the binomial distribution is. And we've talked about this a little bit in class at this point here. The binomial distribution, it's a probability distribution, just a discrete probability distribution. That describes the number of successes, that describes the probability given a certain number, that describes the probability of a certain number of successes given a number of trials and a probability of success for each trial here. So let's just write that down so that we have that in mind. Let me pull this up here. Maybe I won't trip over my words this time here. So the binomial distribution is a discrete probability distribution that describes the probability of a given number of successes in a binomial experiment with a given number of trials, which we symbolize with the letter n, and a given probability of success, which we symbolize with p, for each trial. So hopefully as you're using this later on, you'll go into this sheet here and you'll wonder, what is this for again? And you'll be able to look here and see, okay, that's what that's for. Very, very nice. Lastly, let's take a look at these output parameters. We just have to do the output parameters and then we are all set with this sheet here. So how do we find the mean of a binomial distribution? You might already know what this is here. Let me zoom in. We find the mean by simply multiplying these two parameters here. It's n times p, isn't it? That's the formula. So let me just do that formula here. That's equals, since it's going to be a formula, it is this, shift 8 for the asterisks there, that's times. So this times this. We're hitting enter. And it automatically calculates here that the mean for this should be 8. Let's see if that's consistent with what we see here on the graph. As it turns out, yep, it is. 8 is right here. You can see that's right in the center of the distribution there. What's the formula for variance? Well, it's n times p times q, but what's q? Q is the complement of p, so it's instead of the probability of success, Q is the probability of failure. And so since success and failure always have to add up to 1 in these experiments here, then if P, for example, is equal to 0.8, Q has to be equal to 0.2. All right, probability of failure is 20% if the probability of success is 80%. So another way of writing this is going to be N times P times 1 minus P. Since Q is the probability of failure, the probability of failure is going to be 1 minus the probability of success. Okay, so let's type that in here. Again, this is a formula, so we start with equals, and it's going to be N times P times, and in parentheses, 1 minus P. End parentheses. That's our variance. Okay, and for this instance, you should get 1.6. What's the relationship between the variance and the standard deviation? Well, it's the same as always. The standard deviation is just the square root of the variance. So that's going to be a formula. We start with equals, and the function for square root on Google Sheets is SQRT. And so SQRT parentheses, and I want the square root of whatever this is, end parentheses. And as you can see, it automatically calculates that for you. Okay, and as you change these parameters, it should automatically update these as well. See, very, very nice. All right, lastly, these are by far the most challenging to do here, and it's going to involve a pretty challenging formula here in order to calculate some of these things. Let me start here with the best that I can do here. What we want to do is, first of all, this is going to involve two functions called index and match, and the way that this is going to work here is that it's going to essentially it's going to locate let's see if we can first of all describe numerically what this percentage is here. For the first percentage, another way of writing that as a decimal would be 0.01. So we'll have this here. For the fifth percentage, that's going to be 0.05. 10th percentile, that's going to be 0.1. 25th is 0.25. This is 0.5, 0.75, 0.9, 0.95, and 0.99. Okay. This will make it so the formula is a little easier. And so what we want to do in order to make this work is essentially we want to look for this number in this list here. And we're asking the question, when does this number first cross what's in this list here? Okay, so let me just show you the formula here. We're going to start with a formula. So this is, let me scroll up here so you can see. That's going to be equals match, and we're going to match this number here in this list. So I'm starting at the top here of my cumulative distribution and going all the way down here to the bottom. Okay, so for me that's I4 colon I54. Okay, so I have a search key, I have a range, and the search type, just put in the number 1. It's not autofill yet. Okay. Now, what this is saying is that I'm first finding 0.01 at the fifth. My match here with 0.01 is happening at the fifth of each one of these cells here. We're going down the list and counting 1, 2, 3, 4, 5. Well, that's the last cell before the next one crosses 0.01. Okay, so at this cell here, the next one's going to cross 0.01. Okay. And so we actually want the one that is right after this. And so I'm just going to add 1 to this. Okay, so instead of 5, it's 6. So we're now looking at this one right in here. I've also found that there are instances in which this sometimes will give an error. And so I'm going to show you just another, let me zoom in here so you can see this. I'm going to show you here another command that helps to handle this. And this command is called if error, left parentheses, so if err or r, if error, and then just enclose all of this, make this whole thing the first parameter here. So go to the end and hit a comma. And then type a 1 and a right parentheses here. So all this is saying is that if this returns an error, just make it a 1. Alrighty. Okay, so how does that help us to be able to locate, okay, the point where 0.01 is going to be found on this list here. 1, 2, 3, 4, 5, 6. Okay, so it gets found there. So what? Well, what we really want to find out is what's the value in this X column that corresponds to this value right in here. What we're finding here is that the first percentile is 5. Okay, because at 5 we have, essentially less than 2% of the data has a value that's 5 or less. Okay, 2% of the probability. There's a less than at the point where at the point in the distribution where 1% of the data is to the left of it. Let me explain that better. What we're finding is that only 1% of the possibility, there's only a 1% possibility that the number of successes will be 5 or less. There's only a 1% probability that the number of successes will be 5 or less. In this case, it's 2%. But if we're going to ask what is the value here of x below which only 1% of the probability occurs of it happening, the answer is 5. 5 here is the 6th element in this list. And so what we want to do is to basically index this value on this list here. So that's actually another command here. Let me go up, and after the equal sign, I'm now going to type the word index. Okay, of which the for this first parameter here for reference, it's going to be everything in this first column here. So starting with x equals 0 and going all the way down here, including the blank sections, all the way down to the bottom. All of that gives us our first parameter here. And I'm going to hit the comma so that now we're finding out it's in this row here. And if I click to the end of this, I'm just going to hit another parentheses. And what it's actually showing here is the value in this column that is the 6th element in this column. So it's giving us here the first percentile of this distribution. We're reading what's on this cumulative distribution here to find out where the percentiles are. So, for example, the median is going to be 10 on here, because it isn't until we get, within 10 we cross over in the cumulative distribution from 0.41 to 0.58. So the point at which it passes 0.5 is here on this value of 10. So we're using this cumulative distribution here to find out what these percentiles are. Let me first of all mark off places where these references need to stay the same. And so this G4 to G54, these things need to stay the same. A12 doesn't have to stay the same, but I4 to I54, that definitely has to stay the same. And that's pretty much it. Okay, hard part's over. That was the hardest part right there. All I have to do now is fill this down. And it's now showing you all the percentiles. It's going from the first percentile all the way up to the 99th percentile. You can see here that the median, of course, is 10. That makes sense. You're flipping a coin 20 times, so the median should be 10. But the 99th percentile is 15. So only 1% of the time should you have more than 15 heads or tails when you're flipping a coin 20 times. Similarly, here we get a value of 5 here for the first percentile. You can see the first quartile is 8, third quartile is 12, so it maps it out very, very nicely here. Lastly, we don't need to be able to see these here. They're used by the program, but we don't have to see them. So let's once again make the text color white here. And I think we'll be able to shorten this column a little bit so that that's not getting in our way. Let me zoom out now. Not that much. To take a look at the whole thing. So we have a sheet now that's capable of calculating the binomial distribution given a certain set of parameters. And it calculates not only the full distribution, but it also graphs it, gives its mean, variance, standard deviation, and a set of percentiles for you. All right. It also gives a description of how this is used. The only other requirement that you have to have in order to complete this project successfully, at least this part of the project, remember we also have to do that other spreadsheet for the normal distribution, is to include a certain number of colors, a certain number of fonts to be able to spice it up in a way that looks nice to you. So hopefully that's helpful there. I know there was that crazy formula there for the percentiles. Hopefully that was pretty straightforward on how that was calculated. But I think you're going to like this distribution here. It's kind of cool in what it describes, and we're going to be able to use it an awful lot as we're doing a lot of problems here in stats class. So take care. We'll talk to you soon. I'm going to post another video that talks about doing the same thing for the normal distribution.